Okay, illustrative math, Algebra 2, lesson 4.2 is called Representations of Growth and Decay. All right, so our goal today, understand that exponential functions change by equal factors over equal intervals. So factor is something that you multiply. It's an important word to make sure we understand. And exponential function is a function where the variable is in the exponent, okay? So, quick little review before we jump into this. So, given the following exponential function, identify whether the change represents growth or decay and determine the percentage rate of increase or decrease. So, you got to look at the number here to the exponent. So, remember, this is like 1 plus 0.362. So, this is going to be an increase by 36.2%. Okay, this is gonna kind of like 1 minus 0.03. That's how I got to the 97. So this is a decrease by 3%. And this is kind of like 1 plus 0.04. So that's kind of like an increase by 4%. Now you might say, well, what are these numbers here at the beginning? These numbers, these are your initial values. So it's like you're starting at 8,900 and you're increasing by 36.2% per X, whatever X is. It could be years, could be months, could be days, whatever. This is like you're starting at 28 and you're decreasing by 3% every X interval. And same thing here, start at 540, but this time you increase by 4% every X interval. So what we're going to do with this kind of format here is I kind of wrote this out here. So an exponential function is kind of like this. It's like y equals a times b to the x. So a is your initial amount. Now b, we call that our growth or decay factor. A factor is a number you're multiplying by. So if you think about this here, like let's say, I don't know, let's just pick this one, the 540. It's like you times it by 1.04 repeatedly. Okay. So 540 times 1.04, I get 561.6, and if I do it again, and you could keep on going however many times you want. So I get 584.064. So this is your factor. You keep multiplying by 1.04 essentially. So that's where that comes from. So 1 plus r gives us the growth, 1 minus r gives us the decay. That's how I figured it out there, if I'm increasing or decreasing. So increasing is a growth, decreasing is a decay. So these functions here will be growing like that, and this one's going to get smaller. It's going to decay. All right, so on to the lesson. Here's the warm-up. Priya borrowed $160 from her grandmother. Each month, she pays off 1/4 of the remaining balance that she owes. So I guess what's remaining is 3/4 if she pays off 1/4. Okay, 1/4, because 1 minus 1/4, you're taking away 1/4, would mean that 3/4 remains. So basically, 160 is at 0, but after 1 month, if I times it by 3/4, okay, or 0.75, I get 120. So that's after 1 month times 3/4. So that's going to give me 90. So after the 3rd month, you end up with 67.50. So that's how much she has remaining. So what amount will Priya pay her grandmother in the 3rd month? So you'd have to subtract these to figure out how much she actually paid. So it would be like 90 minus 67.5. I get 22.50 is what she paid for that. So you got to make sure you read that carefully. All right. So that's how much remains, and that's how much she actually paid her. All right. So discuss with the partner why the expression 160 times 3/4 to the third represents the balance Priya owes her grandmother at the end of the third month. So it's kind of like here, here's the path I start here with. I got a lot of numbers here, but it's really like 160 times 3/4 times 3/4 times 3/4. So, you could, if I didn't want to find these months, I could just kind of bypass them and do times 3/4 times 3/4 times 3/4. But rather than do that, it's probably just quicker and easier to just take 3/4 to the third power there. Make sure I got all those questions. All right. So next time we're going to increase. So tuition in a college is going to be increasing. It always goes up. So starting out at $30,000 in 2012, 31,200 in 2013, 32,448 in 2014. So the tuition has been increasing by the same percentage since 2000. So I don't know which. I think your book should have I think your book has a C here because this has a C and then this had an X. I'm not sure which one your book has, so I'm gonna say C for college. I don't know if it's an X or not, but I know they don't match up, so that doesn't make sense. But here's my equation. It represents the cost of tuition in dollars as a function of T. The number of years since T. So T is the number of years since 2012. Explain what the 30,000 means. So that's the initial tuition in 2012. And the 1.04, so we would say 1.04, we'd call that our growth factor, because that's what you're going to be multiplying by every year. But really, it's 1 plus 0.04. So that's how I get the 4% increase each year. Okay. So what's the percent increase in tuition from year to year? So I kind of already said that it's 4%. How did I get that? Well, I looked at the number here, the 1.04. What does C of 3 mean? So that's the tuition cost 3 years after 2012. So 2015. So it's going to be C of 3 equals 30,000 times 1.04 to the third. So it ends up costing $33,745.92. Okay. Write an expression represent the cost of tuition in 2007. So you kind of got to go back in time. So if 2012 is year 0, 2011 is -1, 2010 is -2, 2009 -3, 2008 is -4. So you end up getting 2007 is -5. So I'm going to have to do C of -5 is going to be 30,000 times 1.04 to the -5th. So I end up getting 24,657 81. All right, so that would be your answer. Kind of tricky there. All right, a small business bought a van for $40,000 in 2008. The van depreciates by 15% every year after its purchase. Which graph correctly represents the value of the van as a function of years since its purchase? Be prepared to explain why each of the other graphs could not represent the function. So obviously this is out because it's the growth. It's growing. It's getting bigger. So the initial value is 40,000. So you want your y-intercept to be 40 because it's in thousands. So I can get rid of this one. Y-intercept is not 40,000. So then it's down to these two. So if you're depreciating by 15%, you're going to basically be multiplying it by 0.85 because 1 minus 0.15 gives me 0.85. So what I need to do is I need to take 40 times, not 1, times 0.85 and see what that gives me. 40 times 0.85 is 34. So at 1, we should have 34,000. So right there. So that would make sense. So that's out. So this would be it. Okay. So be prepared to explain. So I kind of went through that a little bit there and mentioned it as I went. Find the value of the van 8 years after its purchase. So they don't give me an equation, but remember we said y equals initial value a times b to the x. So, y is my final value. It represents the initial is 40 times 0.85 to the x. I'm going to plug in 8 for x, and that'll give me the value because you basically times it by 0.85 every year for 8 years. So start at 40 times 0.85 to the 8th, and it's worth 10.89. And we'll just call it, I'm just going to round up to 10.9. So remember that's thousands, so 10,900 approximately. In the same year, 2008, the business bought a second van that cost $10,000 less than the first van and depreciates at 10% per year. So that means we're retaining 90%. What would the second van be worth? Would the second van be worth more or less than the first van 8 years after the purchase? Explain or show your reasoning. Okay, so we're going to say you start out with 10,000. This time it's times 0.90 to the x, but I'm going to plug in 8 for x. There you go. Initial value 10,000. 0.9 is 1 minus 0.10, 0.90. And there we go. So I just plug that in and see what I get. Oh, wait, no. Oh, shoot. This is 10,000 less. Whoops. Caught that barely. It would be, the initial one was, so it's actually going to start out at 30,000, right? 10,000 less than the first van. So that would be, that'd be 40,000 minus 10,000. That's how I got the 30,000. All right. So there we go. I knew that wasn't right because obviously if it was 10,000, it was already going to be less. So I get 12.914. So that's $12,914. Would it be worth less? No, it would be worth more. So it would be worth more. Okay, so it goes to show you the depreciation is really, really huge with vehicles or any type of exponential decay function. All right, on the same coordinate plane as the graph you chose in the first equation, sketch a graph that shows the value of the second band in dollars. Okay, so I'm going to go back up here. So you're going to start, and this is kind of annoying because it's really small, but you start at 30,000, and then I probably need to plug in some numbers here. So if I plug in like, I don't know, one, I don't know, I'm going to plug in 2 and 4. I'm not going to plug in everything. So it's going to be 30 times 0.9 to the second. Let's see what that gives me. And I'm going to do 30 times 0.9 to the fourth, and I'm just going to kind of connect the dots there. So 30 times 0.9 to the second, so this is 24.3. So at 2, I go kind of like right there, and then 30 times 0.9 to the fourth, I get 19.7. So at 4, I'm kind of like right here. So it's going to be kind of hard for me to connect these dots on such a small graph, but I'll do my best. Oops. It's going to be something like that. All right, and obviously they're going to cross somewhere because we know that this one is more than the other one, so it's got to cross it somewhere. All right. All right. So a car costs $20,000 and loses 20% of its value every year. Discuss how equal factors show up in the description, a table, a graph, an equation representing the situation. Okay, so description. I mean, I guess here's my description right here. So, I'm not going to really do too much with that one. So I'm just going to kind of put that right there. So I might jump to my equation next. So your initial value is 20,000, and you could do it in thousands. You don't have to write 20,000. You put 20 and then just make sure you know it's in thousands, or you could write it out the whole number. But it's losing 20%. So 1 minus 0.2 gives me 0.8. So that's my decay factor. So it's 0.8 to the x. There's my equation. So there's my initial value. There's my decay factor. The 20% comes into play right here. Okay, that's how I got the 0.8. All right, so if I wanted to sketch a graph, maybe go to a table next. Let's see here. If I made a table, let's see here, x and y. So if x is, so my initial value I know right away is 20,000. Plug in 1. So if I plugged in 1 to this function, I get 16,000. Plug in 2. 20,000 times 0.8 to the second gives me 12,800. And you can keep going as far as you want. I get 10,240 there for the third one. So if I wanted to graph that, it would look something like this. So here's my 1, 2, 3. Make sure you put X is years since, when was it? And it doesn't say. Years since, let's just say purchase, maybe. And this is the value. So at 0, oh, you know what? I need to get some numbers here. Let's say 5,000, 10,000, 15,000, and up here is going to be like 20. So this is your initial value. Year 1 is at like 16. Year 2 is at 12.8. And year 3 is at 10. So it almost looks like a straight line, but you should know that it's going to curve eventually. All right, so it should look a little bit more banana shaped there. All right. So discuss how equal factors show up in the description. So your description, that's your initial value. This is your initial value at 0. This is your initial value in front, and your initial value is on the y-intercept. Your minus 20%. You have to figure out that you're times it by 0.8. So your 0.8 is right there. You don't see the 0.8 in the table, but if I divide 16,000 by 20,000, that would give me 0.8. If I divide any of these numbers by the previous number, it'll give me 0.8. And then same idea here, you'd have to take this value, divide by that to get the 0.8. All right. So a couple other things here, some bonus questions here. An element with a mass of 990 grams decays by 13.7% per minute to the nearest minute. How long will it be until there are 180 grams of the element remaining? So you start out at 990. You're going to do 1 minus 0.137. So my decay factor is 0.863, not a growth because it's less than 1. So I'm going to just kind of trial and error until, this is to the x. Plug in a bunch of different numbers here until you get a number less than 180. Okay, it says to the nearest minute. So I don't know, maybe I'm going to, I'm plugging 990 times 0.863 to the fifth. Not small enough. It's like 473. 990 times 0.863 to the 10th. 226. Still not. I'm just going to kind of trial and error it until I get it less than 180. So I did to the 15th. That was 108. So 15 was 108.6. So I need to get smaller than that. 990 times 0.863 to the, let's try the 13th. 13th was 145. Maybe try the 12th. $169. I'll try the 11th just to see. $11th was not below 180. It was 195.8. So after 12. So the answer is 12 minutes. Okay, so you keep plugging in numbers until you get it less than 180. So 12 was the first one. Now you'll learn a better way than trial and error, but that's about the only way that you probably know how to do this right now. All right. $3,200 is placed in an account with an annual interest rate of 8%. So we're going to times it by 1.08 to the nearest tenth of a year. How long will it take for the account value to reach 9,000? So my Y's always look like G's. So again, just start trial and erroring it. Plug in a bunch of numbers until you get it. Let's see here. So let's see here. Okay, so this one's going to be a little bit more tedious. So I went ahead and did a little math here on this one, kind of off to the side. So you're just going to kind of plug in numbers until you get, greater than 9,000 and try to get it as close as you can. It ends up being 13.4 is the number. So 3,200 times 1.08 to the 13.4. Let's see if it's a little bit over 9,000. Type it in and I get oh wait, actually I didn't quite get 9,000 on that. So it might actually have to be 13.5 actually, because 13.4 gave me 8,975. Didn't quite reach it, so I'm just plugging in numbers here. Let's try up one more. 3,200 times 1.08 to the 13.5. There we go. That's 9,044. So yeah, so actually scratch that out. It's 13.5 years. All right. All right, so I understand that exponential functions change by equal factors over equal intervals. Obviously, you multiply by the same factor. All right, on to this last thing here, the cool down. In the week that ended on January 4th, there are 24 cases of the flu represented in the city's hospital. So that's right there, the 024. In the 5 weeks that followed, the number of cases reported each week had grown exponentially and can be modeled by this graph. Which expression represents the number of cases of flu? I think I should say X weeks after January 4th. Explain what each number in your chosen expression means in terms of flu cases. So initial value is 24. So remember, it's Y equals A times B to the X. So it's got to either be A or D, because this is not to the X power. This is not times, so you can get rid of those. If I wanted to figure out what it was being multiplied by, 24 times b to the first power, because this is 1 for x here. So I'm just going to say b to the first equals 36. I could now solve for b, actually, because this is b to the first. So if I just divide by 24, I get 1.5 equals b. So that actually works right there. 24 times 1.5 to the x power right there. So that would be D. All right, if the trend continued, would the number of cases reported be greater than 300 after 5 weeks? And then I found my formula. I can plug in 5 for x. And I'm going to just see what I get. If it's greater than 300, our answer is yes. And I did not get 300. I got 182.25. So the answer would be no. Okay. All right. Thank you for watching, and I hope you enjoyed this video.